The asteroid didn't kill the dinosaurs. The darkness it created did. 66 million years ago, a rock the size of a city slammed into Earth at 45,000 miles per hour. The explosion was 10 billion times more powerful than the Hiroshima bomb. We call it the Chicxulub impact, and for decades, scientists said that blast alone wiped out the dinosaurs. But here's what they got wrong. The asteroid was just the trigger. What actually killed 75% of all life on Earth was what came next: 18 months of total darkness, a collapsed food chain, and a planet that forgot how to grow things. The Chicxulub asteroid was approximately 10 kilometers wide, roughly the size of Mount Everest. It struck what is now the Yucatan Peninsula in Mexico, releasing energy equivalent to 21 trillion tons of TNT. The impact vaporized rock and seawater instantly, sending a column of superheated debris into the stratosphere. Wildfires ignited across entire continents within hours. Earthquakes measuring magnitude 11 rippled across the planet. Tsunamis hundreds of meters tall flooded coastlines thousands of miles away. But the physical blast, as catastrophic as it was, lasted only days. The real extinction machine was already launching itself into the sky. The vaporized rock and soot from global wildfires formed a dense stratospheric dust layer that circled the entire planet within weeks. This layer was so thick it blocked 99% of sunlight from reaching the surface for an estimated 12 to 18 months. Without sunlight, photosynthesis stopped. Plants died within weeks. Phytoplankton in the oceans collapsed. The entire base of every food chain on Earth simply vanished. Surface temperatures dropped by as much as 15 degrees Celsius, a phenomenon scientists call impact winter. Large animals that needed massive quantities of food to survive had nothing left to eat. The darkness didn't kill them directly. It starved everything else first. So who made it through? 3 groups survived the darkness in ways that still fascinate scientists. Crocodilians endured because they could go months without eating, slow their metabolism to near zero, and live in water that maintained more stable temperatures. Small mammals survived because they were already nocturnal, lived underground, and could eat insects, seeds, and fungi, organisms that don't need photosynthesis. And birds, the direct descendants of theropod dinosaurs, survived because their small size meant they needed less food, and many could eat seeds that remained buried in soil long after the light vanished. Size was the decisive factor. Anything that needed to eat large amounts every day was eliminated. The recovery was agonizingly slow but unstoppable. Within 3 years, enough sunlight returned to restart basic plant growth. Ferns were the first to recolonize barren ground, a pattern geologists call the fern spike, visible in rock layers worldwide. Full forest recovery took approximately 30,000 years. But in those recovering forests, mammals found an opportunity that had been locked away for 165 million years while dinosaurs dominated. They diversified explosively, from small insect eaters into every ecological niche the dinosaurs had occupied. Within 10 million years, the ancestors of whales, horses, primates, and elephants had all emerged. The extinction that ended one world quietly assembled the conditions for ours. The most powerful events in Earth's history are written in rock layers, fossil records, and the surviving species we share the planet with today. Subscribe to Curious Science to keep reading them. What moment in deep history do you want us to explore next? Tell us in the comments.